An example problem for a system of pulleys is, let's say we have a 10 kilogram block and it's being held in place by some force F that's being applied to a rope that's being passed over two massless, frictionless pulleys. And we want to find the tension on each of the ropes and the amount of force that's being applied to keep everything in place. So the first important concept we're going to look at is that our net force is equal to 0. We know this because nothing's moving, and if nothing's moving, we have no acceleration being applied, so our sum of our forces are going to cancel each other out. So let's look at the tension on the first rope. That is going to be directly equal to the gravitational force that's pulling down on the block. And for this example, we're going to temporarily ignore directions, because right now we care about magnitudes of forces, not directions, but it's important to note that the tension force is directly opposite the gravitational force. But the magnitudes are going to be equivalent. And the gravitational force is simply the mass times the acceleration due to gravity on Earth. So that's our first tension force. Our second tension force is actually going to be equal to our first tension force minus our third tension force. Or another way we could write this is that the first tension force is equal to the combination of those two ropes, 2 and 3. And 2 and 3, because they're on the same pulley system and they're acting in direct opposition to each other, they are actually equivalent. So I can say that they're exactly half of the tension force from 1. So they are equal to 1/2 the mass times the gravitational times the acceleration due to gravity. Now let's look at the fourth tension. The fourth tension is going to be equivalent to the second plus the third plus the fifth. Before we break this one further down, let's look real quickly at tension force 5. Tension force 5 is actually only going to be equivalent to tension force 2. Tension force 3 doesn't affect tension force 5 because tension force 3 is on the center of the pulley. And tension force 5 and 2 are on opposite ends of the pulley. The pulley is not spinning, so they are equivalent, which we found tension force 2 to be 1/2 the mass times the acceleration due to gravity. So that tells us that tension force 4 is then equal to 1/2, 1/2, 1/2. So we have 3/2 the mass times the acceleration due to gravity. And then now the final thing we need to look at is this force we need to apply to keep everything from moving. If nothing is moving, then this force has to directly oppose tension force 5. So the magnitudes will be equivalent. And we found the magnitude of 5 to be 1/2 mass times gravity. So after we plug in our mass and our gravitational force being 9.8 meters per second, we get that our first tension is 99.96 newtons. Our second tension, which is equal to our third tension, which is equal to our fifth tension, which is equal to our force that we're applying, is 49.98 newtons. And our fourth tension is 149.94 newtons.